Alright, this is your first video lesson, and this is the first SOL you are learning as a 6th grader at Thornbury Middle School. And this is SOL 6.4, and it's exponents, perfect squares, and powers of 10. You can follow along with me on the notes in this video on page 1 after your multiplication chart in your notebook. Please write down, highlight anything that I do in the video. If there's anything extra that you would like to write down, you're more than welcome to as well. You can pause, rewind as you need for information that you need to get, or if you need to go back and hear it one more time. If you have questions, please raise your hand and let me know. Alright, jumping right into it. These notes are really kind of already filled in for you on the first page. It just goes over the basic things that you need to know about exponents and what an exponent is. First thing that you need to know is that an exponent is made up of exponents have two parts that go into it. One, the exponent, and then the other thing is the base. The base, or let me highlight it for you. The base is the number that is going to be multiplied. So you see here, base. Base is under the big number. So you can remember base for big. So that when you look at a set of exponents, remember, base is the big number, so the 2 is bigger than the 3, therefore it is the base, and the exponent is going to be the number that tells you how many times you multiply that base by itself. Not how many times you multiply it by the base, but how many times you multiply the number by itself, which is where you're going to get messed up. So the exponent then is going to be this little number right here. The exponent is always going to appear smaller than the base. Whereas it might be hard to see in this example, you can see it much better here. So the 5 here is your big number, therefore it is your base. The 3 is a little number, and it's the exponent. What this means is that the 5 is going to be multiplied by itself 3 times. Just like it has been laid out here. 5 times 5 times 5. There are 3 5s. So your little number should tell you how many numbers of the base you should have. And in this case, it's 3, which is why we have 1, 2, 3. The biggest mistake that people make here is just by multiplying the 5 or the base by the exponent. So you do 5 times 3 rather than 5 times 5 times 5. 5 times 3 is 15. 5 times 5 times 5 is going to give you a bigger number than that, and it's not anywhere close. There are some things to really pay attention to when you're doing exponents. There are some kind of special rules, special things. There are different ways to write exponents, and you will be expected to know and understand all of them. The first way is called exponential notation, which is just writing as a base and exponent. So it just means you should have a big number and a little number. Expanded form would be the second way to write an exponent, and that's just where you write how many times the number is multiplied by itself. So what we have here are 2 different representations of 7 to the 3rd power, except this is written exponentially and this is expanded. So all it is what 7 to the 3rd power means. 7 to the 3rd power means that you do 7 times 7 times 7. The last form is the standard form, and this is just what the answer is when you actually multiply those numbers. So all it is taking 7 times 7 times 7, physically multiplying them, and you get 343 when you do that. Oftentimes you'll be expected to either practice writing all the forms or be able to give an example of at least one of the forms. So you're going to need to understand the differences. However, we're just getting into it, so we'll have a little bit of practice before we get there. Other very, very important rules that are very, very important that you remember. Any number that is raised to the 0 power is going to equal 1. It is going to be, oh, that was not what I wanted to do. It is going to equal 1. Always, always, always. A lot of time, if it's raised to the 0 power, you just automatically think that is going to be 0 because anything times 0 equals 0. However, you're not actually multiplying it by anything except for itself one time, which is 1. So for example, if you had 6 to the 0 power, you see how it equals 1. You could even put it in your calculator if you really cannot remember, because this is a calculator standard. So if you cannot remember, just do 6 to the 0 power, or 3 to the 0 power, 5 to the 0 power, and it will give you 1 every time you put it in the calculator, as long as you're not doing some number times 0. If you do it times 0, it's going to give you 0. The last rule that you really kind of need to remember, and this one is a little bit easier than the 0 rule, is that any number raised to the power of 1 equals itself. So even if you mess up and say, oh, if I do 4 times 1, 4 times 1 still equals 4. So if you mess up, you're still going to get it right on that one, but that's the only one you'll get it right on. So if you do, so what it really is saying is 4 times itself 1 time, which would be just the number 4. All that can equal is 4. This again, if you put it in the calculator, it will always give you the original number itself. Alright, if you go and you finish these notes and go through kind of the questions that I have, after this lesson, once you have finished those, then we're going to move on to another sheet and get a little bit more in depth to this and try a little bit more practice.